Hi YouTube, Tim Unkert here. In this video we're going to write arithmetic series in summation notation with that Greek letter sigma. Okay, so we've got this first one, we've got to write it in summation notation, and we've got the series going 2 plus 4 plus 6, so on up to 202. So the first thing is we're going to write our explicit definition for the series. So we're going to say a sub n, the nth term there, equals the first term, a sub 1, plus the number of terms, n, minus 1 times the common difference, d. Now the difference d is the difference between terms. To get from 2 to 4, you add 2. So d is positive 2 here. Our first term is 2. And so let's work out the right-hand side of this equation and substitute in our values here. So we got 2 plus n minus 1 times 2. And what I'm going to do is just switch the color, be sigma about it. And I'm going to take 2 and multiply it by n, and 2 and multiply it by 1 there, using the distributive property, which is a pretty sigma thing to do. All right, so what we're going to do is we're going to get 2 plus 2 times n, which is 2n, minus 2. Okay, notice 2 minus 2, what is that? Well, that's 0. So a sub n here is equal to just 2n, right? Because, again, 2 minus 2 is 0. All right, so we can write our sigma notation. That's not the best sigma here, but I'm trying my best. And we can write our expression here, so 2n. Okay, we're going to start at n equals 1, but we need to know how many terms we have here to go up here on top. So what we can do is we can take the last term and substitute it in for a sub n, and that's going to allow us to solve for n. So we're going to say 202 here equals 2n, and we'll divide by 2. 2's here will cancel, and we'll get n equals 101. So there are 101 terms in this series, and so we'll put 101 on top here. And that's it. We've written this first one in summation notation, and we use that Greek letter sigma, which I think is pretty important to note. All right, so let's go to problem number 2. We're going to write the following arithmetic series in summation notation, again with a sigma. We should highlight that just so we know. Let's highlight it in purple. So with the sigma there. Okay. So, all right, so we're going to start the same way. We're going to start with our explicit definition. So we're going to say a sub n equals the first term. In this case, the first term is 1. Okay, plus, then we have n minus 1 times the common difference. So to go from 1 to 3 and 3 to 5, we add 2 each time. So we're going to multiply by 2 here. And we want to work this out. We want to use the distributive property. Okay, so this right-hand side, we're going to have the 1 plus 2 times n, which is 2n. And then 2 times minus 1, so we have minus 2 here. Okay? All right, so let's simplify the right-hand side. We have 1 minus 2. That's going to be basically a minus 1. So this is going to be 2n minus 1 equals a sub n. Now so we want to use this with our sigma here. So ooh, that's a nice one. Look at how I drew that one. So we're going to start at n equals 1, and we're going to figure out each term by using the expression 2n minus 1. And now we got to figure out the number of terms. So we're going to take the last term, 101 here. So we're going to say 101 equals 2n minus 1. So we're going to add 1 to both sides. And we're going to go 102 equals 2n. Okay, so let me move this over here. So 102 equals 2n. So we're going to divide by 2. 2's are going to cancel here, and we get 51 equals n. So there's 51 terms in this one. So 51 terms. And we've written this one in summation notation. All right, let's go to the next one. All right, we're going to write the following arithmetic series in summation notation with the sigma. I think we could highlight that and maybe, let's do it this color, do that color and highlight it with the sigma, okay? All right, so we're going to start with our explicit definition. We're going to say a sub n equals the first term, 6, plus n minus 1 times, well, in this case we're going from 6 to 3 and 3 to 0. We decrease by 3, so we're going to multiply by a negative 3. Okay? And what we're going to do is we're going to start to work out the right-hand side. So we're going to do negative 3 times n and negative 3 times minus 1. So the right-hand side is going to be 6 plus a minus 3n, or just minus 3n. And then a minus 1 times negative 3, that's like plus negative 1 times negative 3, so that's plus 3. So if we work this out, our expression is minus 3n, or negative 3n, plus 9. And that equals a sub n. So we're going to start with our sigma here. That's a really good one too. We'll start with n equals 1. And then we have our expression, minus 3n plus 9. And we got to figure out how many terms we have. So let's start with our last term. So negative 78 equals negative 3n plus 9. So we're going to subtract 9 from both sides. So we get negative 87 equals negative 3n. So divide both sides by negative 3. Okay, so how many times does 3 go into 87? Since it's a negative divided by a negative, it'll be a positive, so I'm going to ignore the negatives here. So 3 goes into 8 twice. 2 times 3 is 6. 8 minus 6 is 2. Bring down the 7. 3 goes into 27 9 times, so 29. So n equals 29. There are 29 total terms here. All right. Let's keep going. Last one. We're running out of room. I didn't make enough room here. So write the following arithmetic series in summation notation. So let's start with the a sub n equals the first term 1 plus n minus 1 times the common difference, which is just a positive 1. So it's going to equal 1. 1 times anything is itself, so plus n minus 1. The 1 and the minus 1 cancel, and we just are left with n. So a sub n equals n. So how many terms are in there? Well, 1001 equals n. So there's 1001 terms. Our expression is just n. So we got n equals 1 to 1001. And we don't really need to put this in parentheses because it's just n, but I'm going to put it in parentheses. And that's our summation notation for that one. Hopefully you found this video helpful. If you did, please like and subscribe. Thanks.